Yes, sir.
Okay. So basically, what will be the, thank you, what will be the product at cathode and anode after electrolysis? After electrolysis. In the previous class, that means yesterday, the electrode that I had taken is inactive electrode. That means that electrode will not, electrode, that means anode or cathode, will not take part in main reaction. But there is sometimes we use active electrode. That means we can use either active cathode or active anode, or both the electrodes will be active. Then the product will be different according to the situation. I will explain it, but before that I'm going to give you inactive electrode. That means that electrode will not take part in main reaction. So we have already done for aqueous USO4. Now I'm going to give you, here I'm going to write electrolyte. This is electrode. This will define whether the electrode is active or inactive. Then product at cathode, then product at anode. Now see, so first of all, I'm going to take aqueous AgNO3, and the electrode is platinum or graphite. This platinum or graphite electrode is inactive electrode. Now the second is aqueous NaOH, and this is also platinum or graphite. Now the third is concentrated H2SO4, and the electrode is platinum or graphite. That means in this three questions, I have given you the inactive electrode like the previous classes. Please solve it and let me know the product at cathode and the product at anode. Please do it. And if you are unable to solve it, just let me know. Amjad, did you watch the previous lecture? Amjad. Yesterday. Yesterday you were absent, no? That's why I'm asking. You can reply in chat box. Okay, no problem. Okay.
Sir,
Yes.
can you explain how to do this?
Okay, so let's see. I'm going to explain it. Yes, you were absent yesterday. So did you watch the lecture? I didn't watch it. Okay. So I'm going to explain it and it's very easy. See, all are in aqueous solution. So we have a container. I'm going to explain it from very basic. This is a container in which we have two electrodes. The one is positively charged and the second one is negatively charged. And you know that the negative electrode is called cathode and the positive electrode is called anode. Yes or no?
Yes, sir.
Okay. Now you can see this AgNO3 is present in aqueous solution. AgNO3 is present in aqueous solution. That means there is uh, the quantity of water is also good or much. You can see AgNO3 will be converted into, before that, wait a minute, please, sorry. This is positively charged and this is negatively charged. Now, you can see AgNO3 will be converted into Ag plus NO3 minus, yes or no? Nafisa, Sneha, and H plus OH, H2O will be converted into H plus OH minus. So we know that positive ions will go to negative electrode and negative ion will go to positive electrode. But we have two positive cation and we have two cations, that means positive ion, and we have two negative ion, that means anion. So which one will go first? That we will check. How we are going to check? For cation, we will go for E naught R value. For cation, what we are going to see, which one will have higher E naught R value. The cation which have higher value of electrode potential will go to cathode. Positive will go to negative. So you can see Ag plus has negative value and H plus has positive value. Ag plus has, wait a minute, I'm wrong. H plus won't go. H plus E naught R value of hydrogen is 0 and E naught R value of Ag is something in positive. So we can understand that this Ag plus has more E naught R value. That's why it will go at cathode. So what happens at cathode? You can see at cathode, Ag plus will go and gains one electron from cathode and it will be converted at Ag. So what will be the product at cathode? Product at cathode will be Ag. That means silver will be deposited at cathode. Now come to this point, OH minus and NO3 minus. This is anion. And I had given a PDT, preferential discharge theory, for anion. And this, in according to this theory, NO3 minus will have lesser migration than OH minus. That means this OH minus will migrate to this positive electrode, because you can see the this is ease of migration, SO4 minus 2, then NO3 minus, then OH minus. OH minus is getting more for OH minus it is easier to migrate to positive than NO3 minus. So whenever OH minus will migrate, I told you that there will be 2H2O and then O2 gas and then it will release 4 electrons. So what will be the product at anode? At anode, O2 is evolved. O2 gas evolved. Are you getting my point? Nafisa, Sneha, Hamza, NO3 won't
Yes, sir.
get go there. Please write it and let me know when you are done with this.
Yes, sir. Finished.
Finished. Very good. Now, if you have a question like this, so you are going to write product at anode will be Ag and product at cathode will be Ag and product at anode will be O2. H2O will be in the solution. Wait a minute. What, sir, what is that written on the right bottom side? Evolved. Are you talking about this? O2 gas? O2 evolved. Evolved at anode. So, Nafisa and Sneha, you are going to do for the next NaOH, and I think NaOH you can do that. Concentrated H2SO4, when we will talk about concentrated H2SO4, I will explain that. That is very, very easy. Let me know when you are done with this. So I'm going to slide it up. This was the question. I had already explained for AgNO3, so you are going to do it for NaOH. And for NaOH, it is very, very easy. Nafisa and Sneha and Hamza,
Yes,
can you do
sir.
it?
The product at cathode is Na.
Wrong answer. For cation, there was a trick or there was a rule. Which one will, since we have two cations on and only one of them will go to yeah, it's wrong. Hydrogen anode. Anode is positive and hydrogen is also positive. How can positive will attract each other? They will repel each other, no? So Nafisa, what I was saying is there are two options for cathode as well as anode. So first of all, take the case of cation and see what is the rule for cation. The rule for cation to migrate to cathode is that the one which has higher value of E naught R will migrate first. And there is two options for cation, you know, Na plus and H plus. Na plus metal, that is E naught value, E naught R value is negative. The value of E naught R for sodium, Na, is negative, and the value of E naught R for hydrogen is 0. Which one is greater, Nafisa?
Yes, sir, hydrogen.
Hydrogen. So my hydrogen will easily migrate to that side. So product
Yes,
at
sir.
cathode, Sneha, product at cathode, not anode, is hydrogen. And when we talk about product at anode, so you can see you have both the same. Basically, you can see NaOH. Wait a minute, I'm going to slide it down. So basically, NaOH, when it will be dissociated into ions, it will be Na plus OH minus. And since it is in aqueous solution, so H plus OH minus. So we have decided for this that this will migrate to cathode, and you can see both are same. So one of them will move towards anode, and what it will form? It will form H2O along with
Yes,
O2.
sir.
Just balance it according to yourself. Just balance it. So O2 will be at anode. O2 will be at
Anode.
Yes or no?
Yes, sir. Yes, sir.
Yeah. Now see, I'm going to explain for the concentrated H2SO4, which is very easy. Very good. See, when we talk about concentrated H2SO4, you know that this is H2SO4, and when it will be dissociated, it will be like 2H plus SO4 minus 2. Again, if we have after H2SO4, we have H2O, and since it is concentrated, you know that since it is concentrated, the amount or the quantity of water or solvent is very less. Yes or no?
Yes, sir.
Nafisa, Neha, since it is
Yes, sir.
concentrated H2SO4, that means the quantity of solvent is very less. So we have two electrode. One is positive electrode, anode, and another is negative electrode, cathode. So 2H plus will go to cathode, and H plus will get 2H plus will get 2 electron, and it will be converted into H2. That means the product at cathode will be H2. Now, what about anode? We have only one option left, SO4. So SO4, 2 moles of SO4 we are going to take, and it will, since here it is reduction, there will be oxidation, and it will be converted into S2O8 minus 2, and it will release 2 electrons. So the product at anode will be this, aqueous. Okay.
Yes, sir.
So please write it.
Yes, sir. Finished.
All of you are done with this. Sneha, Hamza, please do reply in chat box. Okay. Now see. So I'm going to write I'm going to just erase it. So this is unconcentrated concentrated H2SO4. This will be, and this will be O8 minus. Yes or no?
Yes,
Now
sir.
see, I'm going to take another example, another question. In the fourth one, I'm going to take aqueous AgNO3. Again, I'm going to take the electrolyte AgNO3, but here the electrode is Ag electrode, and Ag electrode is active electrode. That means this electrode will take part in reaction. Are you getting my point?
Yes, sir.
Now see what happens when Ag electrode will be there. There will be a reduction of Ag. Ag plus will gain one electron and it will be converted into Ag, and the oxidation will be also of Ag. See, I'm going to explain why it happens. Ag plus electron. So I'm going to explain it for AgNO3. So this was only the explanation. That's why I'm just erasing it.
Sir, can you scroll up?
Hamza, what you just said?
Sir, can you scroll up?
Scroll up like this is scroll up. Are you talking about this?
No, not this one.
Or this?
Yes, this one, sir.
Let me know when you are done with this. Are you done with this?
No, sir, one minute.
Okay, okay.
Sir, done.
Very good. Now see what I was going to explain. You can see AgNO3 in the solution. It will be converted into Ag plus NO3 minus. Also, we have H2O. So there will be H plus OH minus. Now you know that in Ag plus for cation we go by the value of E0R electrochemical series. So this one has more value, so it will go to cathode and easily gains electrode and deposited at cathode. Now when we talk about anode, at anode everyone knows that there will be oxidation, but this anode is made up of Ag, and it will have tendency to oxidize more than these two. That's why it will lose one electron and it will form Ag plus. So the product at anode will be Ag plus aqueous. So please write it.
Sir, can you explain again?
Now, what I wanted to say is that you can see this positively charged will go to cathode and reduce itself. At cathode, what happens? It gains electrons, yes or no?
Yes, sir. Yes, sir.
And it reduces itself. But at anode, it oxidizes. Are you getting my point? It oxidizes. That means it is losing electron. So NO3 minus, OH minus, we have already two options for oxidation. But this electrode is made up of Ag, silver, which is more, basically this will be more oxidizing. So it will oxidize itself. So basically it is active electrode. So it will take part in reaction and it oxidizes itself. So it will be Ag into Ag plus plus electron. Got it, Nafisa?
Yes.
Active electrode will take part in reaction.
Yes, sir. Finish.
Everyone done with this? Very good. Now another active electrode, that mercury. So the fifth one is aqueous NaCl, and the electrode will be Hg electrode. So see what happens here. NaCl, we have Na plus plus Cl minus, and we have H plus plus OH minus. Yes or no? Let me know. This will be the positive and negative cation and anion. Yes or no? Now see, up to this, since this is active electrode, we were always taking H plus and reduced it. But here, when we talk about Hg electrode, which is active electrode, basically sodium is highly soluble in mercury. That's why sodium will migrate towards cathode. And what it will form, it will gain one electron and it will form Na. And again, since the electrode is made up of Hg, it will form sodium amalgam. This is called sodium amalgam. And what about anode? You know that Cl minus and OH minus, in this, the ease of migration of Cl minus is greater. That's why Cl minus will go to anode and will form Cl2 gas. Again, I'm going to explain. In all the examples for inactive electrode, we were taking H plus according to E naught R value. But here, as the electrode is active, Hg electrode, we took Hg electrode, and sodium is highly soluble in mercury. That's why Na plus will migrate towards Hg electrode. So please write it.
Okay.
Yes, Hamza, what were you saying?
So,
Sir, can you
You-
explain in the case of Cl minus.
Cl minus. Yes, I can see. We have for basically see whenever there will be this type of question, what you are going to do, just separate it into two parts: positive, negative, cation, anion. Cation will migrate on the basis of E naught R value, and anion will migrate on the basis of PDT that I have written, ease of migration of anion. I am going to show you. See, this is for cation, E naught R value increases, that ion will migrate first. For ease of anions, you can see SO4 minus 2 have lowest ease of migration, and the highest is I minus, Br minus, Cl minus, OH minus. So we had two options, Cl minus and OH minus. Which one will migrate? Cl minus. And Cl minus will go like this, and it will be converted into Cl2, and one electron loses. So this will be the balanced equation.
Yes, sir.
Got its name. Please write it. Please write it.
Yes, sir. Finish.
Everyone done with this? Hamza?
Yes, sir.
So this was about electrolysis. Now we are going to study about Faraday's law of electrolysis. There are two laws of electrolysis of Faraday's. So write a topic. Faraday's law of electrolysis. Faraday's law of electrolysis. So I'm going to write the first law of Faraday. First law of Faraday. So this is very easy. Since we have seen in electrolytic cell that electrical energy is given. So you can see in the diagram that there will be electric current. That means there will be charge also. Since current is defined as I is equal to Q by T. I is equal to rate of flow of charge per unit time is called current. And Q has a formula, Q is equal to I into T. You have already studied this in class 10. Yes or no? Yes or no?
Yes, sir.
So you have seen in electrolysis, there will be deposition of some substances on electrode, or we can call it, there will be evolution of gas on particular electrode according to the electrolyte. Yes or no? If the formation is in gaseous state, we call it evolution of gas on particular electrode, and if the formation of substance is in solid state, we call it the substance is deposited on particular electrode. Is that clear? So basically,
Yes, sir.
that substance, whether it is in gaseous state or in solid state, will be directly proportional to the charge flow in this circuit. If you are going to increase the charge flowing through this circuit, the substances that is deposited on a particular electrode or the substances that is evolved on a particular electrode will be directly proportional. If you are going to increase the charge, the substances deposited or evolved will also increase. If you are going to decrease the charge, the substances evolved or deposited will also decrease. Got it?
Yes, sir.
So basically, this is very easy. So I'm going to write the same statement that I repeated. The mass of a substance, the mass of a substance deposited, or we can call it mass of gas liberated at a particular electrode, at a particular electrode is directly proportional, is directly proportional to the amount of charge passing through electrolyte of solution. Please write it. Then going to derive of.
Yes, sir, finish.
Yes, everyone done with this? Very good. Hamza?
Yes, sir.
Okay. So according to the statement, you can see mass of a substance deposited or mass of gas liberated at a particular electrode. That electrode will be defined according to the situation, directly proportional to the amount of charge passing through the electrolyte of solution. So it's very easy. You can see mass is directly proportional to charge, and this M is mass of substance deposited or mass of gas liberated. And to remove this proportionality sign, we got a constant that is denoted by Z. And this Z is electrochemical equivalent. We call it electrochemical equivalent. And this Z has a formula. Electrochemical equivalent will be equal to equivalent weight upon Faraday's constant. This is equivalent weight. We already know how to calculate equivalent weight. Equivalent weight, and this is Faraday's constant, which has a approximately the value of Faraday's constant is 96,500 Coulomb. So I'm going to just put the value here and we'll get a formula. Another formula from here we can write Q is equal to, since Q is equal to, we know that Q is equal to I into T. So this formula can also be written as ZIT. Can I write it? Nafisa, Sneha, and Hamza.
Yes, sir.
Now another formula at the place of Z, I'm going to put E upon F into Q. Wait a minute. Why does this? Again, we can write this formula according to the situation. We can also write M is equal to E by F into I into T. I is equivalent weight. We know how to calculate equivalent weight. So please write it. Equivalent weight has a formula: molar mass upon X. X is valence factor. Valence factor. Please write all this and let me know.
Yes, sir. Finish.
Very good. Everyone done with this? Sneha, Hamza, please let me know.
Yes, sir. Done.
Very good. Hamza, what about you? So I'm going to give you a question. Find the amount of charge. Sorry, find the amount of copper deposited when 5 ampere current is used for 1 hour to electrolyte CuSO4. It is also given that atomic weight of CuSO4 copper is 63.5 gram. If 1 Faraday is also given, 96,500 coulomb. 96,000. Please solve it.
Sir, can you answer the last?
Yes, Hamza. See, Hamza, it's very easy. You know that we are going to talk about only copper. And since CuSO4, if you are going to dissociate it, it will be Cu plus 2. So Cu plus 2 will gain 2 electron and it will be Cu in solid. So we need to calculate the mass of copper. So we had a formula, M is equal to Z IT. Why I took IT instead of Q? Because current is also given and time is also given, that's why. Now Z has also a formula, E upon F I into T. Yes or no? Hamza?
Yes, sir.
Now see, T is given, I is given, F is also given, and this E has a formula molar mass upon X. What is the molar mass of this? We will not take CuSO4 since we are only talking about copper. The question has been only asked about copper. So we are going to take atomic mass of this, which is 63.5. And what will be the valency factor? So you can see there is only 2 electron difference, plus 2. It is going from +2 to 0. So the value of X will be 2. So I'm going to just put the value 63.5 upon 2 into current is 5 ampere. Time is 60 minutes into 60. It will be in second. And what is the value of Faraday's? 96,500. And you will get your answer if you are going to solve it. And I'm going to give you a very easy trick for solving the question on the basis of first law of Faraday's. Please do it. Done, everyone?
Yes, sir. Sir, should we simplify
Yes.
this?
Yes, you should.
Yes, sir. Okay. Sir,
Yes, what's your answer?
1143 by 193.
No.
No.
Okay, it is not totally solved. Wait a minute. So 63.5. So it will be basically, if you are going to just cancel this, what we will get 11430.
Yes, sir.
Yes,
Yes, 193.
1930.
Yes,
So
sir.
it will be 1143, 193.
193.
So
Yes, sir.
1143 divided by 193, 5.9 gram. This will be 5.9 gram. Is
5.9.
that clear?
Yes, sir.
Sneha, Hamza,
Yes, sir.
very good. Nafisa. Okay, so I'm going to show you. It's very easy. Do you know this 1 Faraday? How does it comes? 1 Faraday
It is
is
going to
approximately, yes, Hamza.
the 1 micron scale up.
Okay, please write it. Very good. 1 Faraday is actually equal to 96,400, approximately equal to 96,487 coulomb. For calculation, we take approximately 96,500 coulomb. Now, do you know this is, since I'm writing coulomb, that means this is the value of charge. Now, everyone knows that charge on one electron, that is equal to 1.6 into 10 raised to the power minus 19 coulomb. Yes or no? Charge on one electron, that is equal to 1.6 into 10 raised to the power minus 19
Yes, sir.
coulomb. But do you know charge on 1 mole electron will be equal to 1 mole electron, that means 6.022 into 10 raised to the power 23 electrons. Charge on 6.022 into 10 raised to the power 23 electrons. It will be approximately equal to what we do, 6.022 into 10 raised to the power 23 into 1.6 into 10 raised to the power minus 19 coulomb. So it will be approximately equal to this value, 96,500 coulomb. That means 1 mole electron charge on 1 mole electron will be equal to 1 Faraday, which is equal to 96,487 coulomb or 96,500 coulomb. Got it, everyone?
Yes, sir.
So please write. Then I'm going to show you a trick which is very easy to understand and solve the question.
Yes, sir. Finish.
Okay. Then Sneha, now see, I told you that in the previous question, you have seen that Cu plus 2 will gain 2 electron and it will be converted into copper solid. Yes or no?
Yes, sir.
Now, in class 11th, you have studied about stoichiometric and exstoichiometric calculus. So if I'm going to write, since we don't deal with this, we don't need it. But if you are going to write 1 mole of Cu plus 2 combined with 2 mole electron to give 1 mole copper. Can I write this or not? 1 mole copper. you have
Yes, sir.
in class 11th you have studied about this CH4 plus O2 will give CO2 plus H2, 2H2. You have studied about this. Like this, 1 mole of CH4 react with 2 mole of O2 to give 1 mole of CO2 and 2 mole of H2O. Have you studied about this?
Yes.
Now see, we don't need this. So I'm going to write 2 mole electron will give 1 mole Cu. 2 mole electron will give 1 mole Cu. 2 mole electron, that means can I write 2 Faraday will give 1 mole Cu? Yes or no?
Yes, sir.
And do you know 1 mole will always be equal to its molar mass? Because if you are going to calculate number of moles will be equal to given mass upon molar mass. What is the mole of Cu? It's given 1. What is the molar mass? 63.5. And mass will be equal to then 63.5. Yes or no? As you know that
Yes.
1 mole is equal to 6.022 into 10 raised to the power 23. As you also know that 1 mole at STP will be equal to 22.4 liter. That's why it should also be known that 1 mole is equal to molar mass. Are you getting my point?
Yes, sir.
Nafisa, Sneha.
Yes, sir.
So 1 mole Cu will have mass 63.5 gram. 63.5 gram copper, can I write it? And at the place of 2 Faraday, can I write 2 into 96,500 coulomb? That means this much charge will deposit this much mass. Yes or no? Initially, it will be lengthy, but after some time, it will be very easy to calculate. Which part, Sneha? Always remember 1 mole is equal to 6.022. You know that 1 mole is also equal to 22.4 liter. So 1 mole will also be equal to molar mass. So what is the molar mass or atomic mass of copper? 63.5 gram. So 2 mole electron will give 1 mole, 2 Faraday. 2 mole electron, that means 1 mole electron is equal to 1 Faraday. Then 2 mole electron will be 2 Faraday. So I'm going to calculate for 1 coulomb. For 1 coulomb, the mass deposited will be this. Yes or no? It's a unitary method. Yes or no? Nafisa.
Yes, sir.
Now you can see I is equal to Q by T, and we can calculate Q is equal to I into T. I is given as 5 ampere and time is 1 hour. So we need to calculate it into second. That means this much charge. We already calculated for 1 coulomb, this much gram of copper deposited. But we need to calculate for this much coulomb. So if I'm going to calculate for this much coulomb charge, so what we need to do is 63.5 upon 2 into 96,500 into 5 into 3600, that is 60 into 60. Same equation came, then the value will be 5.9 gram. The value will be 5.9 gram. So it's very easy. What you need to do is just see how many electron it gains. So the number of electron it gains, it will be in Faraday. So just 2 Faraday, that means this much coulomb charge will deposit this much. So I'm going to calculate for 1 coulomb and then this. Should I slide it up? Please let me know when you are done with this.
Yes, sir. Finish.
Very, very good.
Sir, one minute.
Sneha, let me know if you still have any doubt.
Sir, 1 minute. Can you scroll down?
What you just said, your voice is
Can you scroll down?
always disturbed. Okay, slide down, right?
Yes, sir.
So please write it, and then I'm going to give you some more questions on this. Then, very good. A charge of 1 Faraday deposits obtains 1 option B is 1 gram of substance. Option C is 1 gram equivalent. Option D is 1 substance. Question is very easy. You just need to focus on the question and solve it.
So what's one in D?
1 AMU, atomic mass unit.
Yes.
Yeah, what's your answer? What is the answer? No, the No, answer is not D. See, I'm going to explain it, which is very easy. A charge of 1 Farad deposits 1 mole of substance. It will be equal to 1 mole of substance. Now you know that M is equal to Z into Q. Yes or no? M will be equal to Z into Q. And M, I can write E upon F into Q. How many charge it is deposited? You know that. Wait a minute. How much charge deposited? You know that this is E upon F. F is 1 Faraday given and charge is deposited 1 Faraday. So this will be cancelled. So M will be equal to equivalent weight, that is 1 gram equivalent of substance. So answer is C, not D. Is that clear, everyone?
Yes, sir.
Anja, Sneha, Nafisa. Okay, can I change this slide?
Yes, sir.
Please write it. Sneha and Hamza. Okay, thank you. Moving to the next question. The question is very easy. How long should a current of 0.25 ampere be passed through a molten metal salt to deposit that much weight of matter, which is equal to its electrochemical equivalence. The question is very easy. Please do it. Are you done with this? Is there any answer? Nafisa? Nafisa, please do reply.
Sir, I don't know.
Okay, no problem. So I'm going to explain it. Okay. Now see, it's very easy. Now you can see how long should a current of 0.25 ampere. That means current is given 0.25 ampere. Be passed through a molten metal salt to deposit that much weight of metal which is equal to its electrochemical equivalence. That means mass deposited will be equal to electrochemical equivalence. According to the question, mass is equal to electrochemical equivalence. Yes or no?
Yes, sir.
Now we need to calculate time. So you know the formula, m is equal to z into q. And at the place of q, I'm going to use it because we need to calculate t. So since you know that w is equal to z, so I'm going to write at the place of z m, and I is given as 0.25 into, we need to calculate time t. So you can see m and m will be cancelled. So what we have left, 0.25 t is equal to 1. So time will be equal to 1 upon 0.25. If you are going to remove the decimal, it will be 100 upon 25. So the answer will be 4 seconds. Yes or no?
Yes, sir.
Please write it. It was very easy question.
Yes, sir. Finish.
Very good. Everyone done with this? Sneha? No, sir. Okay. Take your time, wait and let me know. Everyone done with this?
Yes, sir.
Very good. how much charge is required for reaction, following reactions. So 1 mole Al plus 3 to Al. If you are going to change 1 mole Al plus 3 into Al, how much charge is required? So see how we are going to solve it. It's very easy. Al plus 3 will be converted into Al by gaining 3 electrons. Yes or no? Hamza, Sneha,
Yes, sir.
Nafisa.
Yes,
Now
sir.
3 electron, that means 3 mole electron will give 1 mole aluminum. So that means 3 mole electron, that means 3 Faraday coulomb charge is required to make 1 mole aluminum. Yes or no? The question was how
Yes,
much charge
sir.
is required for reactions. So 3 Faraday, that means 3 into 96,500 coulomb charge required for the formation of 1 mole aluminum. Is that clear?
Yes, sir.
Please write it and then I'll see you in the next class. And in the next
Yes,
class,
sir.
we are going to complete the second law and battery part of this chapter. Let me know when you are
Yes.
finished with this.
Yes, sir. Finish.
Okay, you may leave the class.
Thank you, sir.
Thank you.